Lesson 5.1, Solving Inequalities by Addition and Subtraction. Essential question. What information do you need to gather from a word problem in order to write an inequality? So all of the lesson is going to be word problems that we're going to have to write inequalities for. All right, so the first thing we need to do is figure out which words go with which inequalities. So if I start at the top, the first inequality is less than. So I'm going to look for less than. Another one that is the same as less than is fewer than. So fewer than and less than both go with the less than inequality. Then our second inequality we have is greater than. So I'm going to slide up the greater than. And then another one that is the same as greater than is more than. So if you see the words greater than or more than in a word problem, you need to use the greater than symbol. Then we have less than or equal to and greater than or equal to. All right, now we've got 4 left, and these ones are a little bit more complicated. So I'm going to try to explain a real world situation to go with each one. So let's look at least first. So if I say I have at least $5, or I need at least $5 to get into the movie, that means I need $5 or more. So I need at least $5 to get into the movie, so I need to have $5 or more, which would be greater than. If I need at most $4 to buy a pop, that means I would need $4 or less to purchase that. So that would be at most. At most is less than or equal to. Then we've got no less than and no more than. If I say I have no more than 10 students in my classroom, that means I have 10 or fewer students, which would be less than or equal to, so no more than. And if I have no less than 10 students in my classroom, I have 10 or more. So those are a little confusing, but we'll use them throughout the lesson to help us practice them more. All right, first example. So it says, write an inequality and solve. The sum of a number and 6 is less than -3. Now we're going to use an acronym with all of our word problems that are going to help us write them. The acronym is SOUIE, so S-O-U-I-E. The S starts with, O is the operation, U is the unknown, I is the inequality, and E is the ends with. All right, I think the easiest thing to start with every single time is the unknown. Unknown means what we're trying to find out, and that is our variable. So that is where we're always going to put our variable, which usually I'll use X. Okay, the next one that we could figure out, really you can go anywhere you want, but let's do our inequality, because it says right in this word problem what our inequality is. So our inequality is less than, so we're going to put the less than inequality into our problem. All right, now let's do our operation. So the word that goes with operation is sum. Operations are add, subtract, multiply, divide. So sum would be addition, or adding. What is the sum of two things? You're adding them together. Okay, starts with and ends with. Those both need to be a number. So starts with will always be a number. Ends with will always be a number. And usually it'll work to just go left to right in a situation like this. So the first number we come to is 6. So we'll put that on the top. The last number we come to is -3. So that'll go on the bottom. So then our inequality can be written from top to bottom. So go from starts with was 6. Then we have a plus sign. Then we had an X, then we had a less than symbol, and then we had our -3. Which if you read this problem, this sentence should make sense. So the sum of a number and 6, so we're adding x and 6, is less than -3. So now before we're finished, we need to solve this inequality. So subtract 6 on both sides, and we end up with x is less than -9 as our answer. All right, let's go to the second one. Okay, so again, we're going to write an inequality and solve. Twice a number decreased by 1 is at least 17. So we're going to use SUI again. Starts with operation, unknown, inequality, and ends with. Now, not every problem works perfectly with SUI, but I still think it helps you to more easily write an inequality. The last problem worked really nice with SUI. Not every problem is going to be super nice, but it will help. Okay, so let's again start with our unknown, which is always our variable, so x. And then let's write in our inequality. So our inequality on this one was at least. Now, if you have troubles remembering what at least was, you can refer back to our grid. Then you'll see the word at least under the greater than or equal to symbol. So remember I said if I have at least, let's say at least $10, that means I have 10 or more dollars. So at least is greater than or equal to. Okay, then if I go to my operations, there's actually 2 operations in this problem. Twice a number means that you're timesing a number by 2. So we have both multiplication and we see the word decreased by. Decreased by is subtraction. So we have both multiplication and subtraction in this problem. Okay, so then let's look at our starts with numbers. So the first number we come across is twice. So we need a 2. Then we have the number 1 and the number 17. So we have 3 numbers on this problem. So the 2 and the 1 both need to go under the starts with. The 17 is what we'll end with. Okay, so now we're going to use what we've got, and we're also going to read the problem to help us write this inequality. So our starts with is we have a 2 and a 1. So look at the original problem. It says twice a number. So twice a number is that 2 times x. So this right here is the twice a number. Then we have the decreased by 1. So that's going to be the -1. Then we have greater than or equal to 17. So now if I go ahead and solve that, I've got train tracks. The x is what I need to get alone, so I'll add 1 on both sides. Then I've got 2x is greater than or equal to 18. Divide both sides by 2. And we've got x is greater than or equal to 9. So use SUI as a way to get you started, but also know you've got to read the original problem to make sure that you write things in order, because you can't always just go from top to bottom to write your inequality. All right, now we've got a real-world situation that we're going to work with here. So Sam has $65 to spend at the mall. He bought a t-shirt for $18 and a belt for $14. If Sam wants a pair of jeans, how much can he spend? So let's start with our unknown this time, once again, and that is, rather than just x, I'm going to use a variable that has to go with what we're trying to find out. Sam wants to buy a pair of jeans. We want to know how much can he spend. So I'm going to put a J there for the jeans. That's what we're trying to figure out. How much can he spend on the jeans? All right. This problem doesn't give me an inequality in the sentences, so I'm going to leave that blank for right now. Let's go to operation. So I want you to think about this. If you're buying things, so if you're at Target buying a t-shirt and a belt and jeans, what operation is the cash register doing while you're purchasing these things? It is adding them up. It's saying 18, then you add 14, then you add the price of the jeans, and then the cashier gives you a total. So the cash register or the cashier is adding up all the items you want to buy. So that's the operation you need. The other thing that's a little bit different on a real world word problem is we're going to do something a little different with the starts with and the ends with. Anytime we're dealing with money, so we have $3 amounts, I want you to put the biggest dollar amount at the ends with. So 65, instead of going in the starts with, is going to go in the ends with. It's always the biggest dollar amount. So then our starts with is going to be the 18 and the 14. Okay, we're going to write our problem right now actually without having our inequality symbol. And we're going to put that in at the end, and I'll show you why in a minute. Okay, so I don't want to go up too high here because we can't see our numbers. Okay. So Sam is going to the mall. He is buying an $18 t-shirt, plus he's also buying his $14 belt, plus he wants to buy a pair of jeans. He has $65 to spend. So this right here is the amount he can spend. This is how much he is spending, or the cost of the items. So we'll say items, item cost. So you have to think about it. Can his items cost more than the amount of money he has? So he has $65. He cannot spend more than $65. So the cost of his items has to be less than the amount of money in his pocket. So it has to be less than or equal to. So let's go ahead and solve this. So I'm going to add together 18 and 14, and I'll get 32. And then I'll subtract $32 on both sides. So here's what this means, and for real world problems, we're going to write a sentence when we're done. This means that the jeans, because it's less than or equal to, so the jeans can cost $33 or less. So what you have to keep in mind with an inequality is that the answer isn't just 33. The jeans don't have to be $33 exactly. They can be $33 or any amount under that. And then he just have extra money left over. So he can spend $33 or less on the jeans. Okay, last one. Jose plans to spend no more than $50 on 2 shirts and a hat. If the shirts are $10 each, how much can he spend on the hat? So we want to know how much can he spend on the hat. So hat is what we're trying to solve for. So how much can he spend on the hat? So I'm going to put an H there for hat. All right, this time they give us an inequality. They give us no more than. So let's go back to our chart from the beginning. No more than is less than or equal to. So if I have no more than 15 students in my class, that means I have 15 or fewer. So less than or equal to is no more than. All right. Our operation, once again, he's buying things. He wants to buy some shirts and a hat. So all of those items would get added together. The cost of them would get added together at the store. And then we have a couple numbers here. So we have our big $50 That's the big dollar amount, so that's our ends with. We also have $10 for our starts with. Now, one tricky thing about this problem is you're also going to notice one more number. We have the word to here. So let's go back and see what that is. So Jose plans to spend no more than $50 on 2 shirts and a hat. Each shirt is $10, but he's buying 2 of them. So really, we can say that this is 10 times 2 or just make it 20. So rather than doing 10 twice, let's just make it 20. Now we can write this inequality pretty easily. So we have $20 for the 2 shirts plus the price of the hat has to be less than or equal to 50. So if I draw train tracks and subtract 20 on both sides, I have H is less than or equal to 30. So what that means, if we write a sentence, is that Jose can spend $30 or less on the hat. And that's because its H is less than or equal to, so his hat can be $30 or less. Summary.